All right, so greatest common factor is just the factor that each term has in common, the biggest one, right? So if you look at something like this, for example, we can break these down as much as we can and try to find the biggest number that multiplies into both terms, right? So some words that you might hear me say are terms. Remember, a term is anything separated with a plus or a minus. So because I see a minus here, this is one term, this is another term, right? So you need to be comfortable with hearing those words. All right, a factor, when I say find the greatest common factor, it's anything that is being multiplied with something else, right? Again, factor is anything that's being multiplied with something else. So let's look at each of these terms. We can go piece by piece. All right, so let's start with the coefficients. Between 6 and 4, what's the biggest number that they share in common as factors? 2, right? So 2 is our greatest common factor of 6 and 4. What about x to the third and x? How many x's do they share in common? Just one x. So 2x, this is going to be the greatest common factor. All right, left over inside of the parentheses are just going to be whatever we get when we divide by the greatest common factor. So let's divide 6x to the third by 2x. When you do 6x to the third divided by 2x, what does that give you? Good, 3x squared. And then let's do the same thing with 4x. Divide 4x with 2x, what does that leave you with? Just a regular 2, and then you're going to keep the sign in the middle. I should still have 2 terms on the inside, my greatest common factor on the outside. All right, is that something we kind of remember from algebra? Good. All right, so let's try a couple of these examples. Let's go one at a time. Let's start with this first one. All right, so between negative 4x squared, 12x, and 16, right? This is kind of like an unwritten rule, but we like to, if whatever's in front, if there's a negative out front, we like to pull that out as well. So between negative 4, 12x, and negative 16, what's the biggest factor that they share in common? Sure, yeah, let's do negative 4, right? So this is going to be the same as negative 4. And then let's look between x squared, x, and no x's. Do they share anything else in common? No, right? Because not all of them have an x, right? Only 2 of them have an x, but for it to be a greatest common factor, it needs to show up in all of them. So that means negative 4 is our greatest common factor. There's nothing more we can pull out. So then let's write the parentheses right next to it. So what was our process for that? How do we get what's inside here? Very good. Divide everything by the greatest common factor. So let's divide negative 4x squared by negative 4. What does that give you? X squared. All right, so it gives you 1 as the coefficient, but then keep in mind there's still the x squared there. What about positive 12x divided by negative 4? Good, negative 3x. And then what about negative 16 divided by negative 4? Positive 4. So this is your factored expression. Okay, so what about the next one? Let's look at 3x to the third, negative 6x squared, and 9x. Let's look at the coefficients first. Between a 3, a 6, and a 9, what's the greatest common factor? 3, good. And then there's an x as well, right? X to the third, x squared, and x. They share one x in common, so I'm going to pull out the 3x. And then I'm going to write the parentheses. All right, and then to get what's inside of the parentheses, we can divide everything by this greatest common factor, right? So I'm going to divide everything by 3x, 3x, and 3x. All right, what do I get in that first term? Good, right? Just x squared. 3 divided by 3 goes away. X to the third and x make an x squared. Good, minus 2x. And then what's the last one? Plus 3. Nice. And so this is our factored expression. All right, the next 2 is where some people get confused. Just because the way it looks like there's more going on here than is actually going on, right? Keep in mind, GCF, what does the F stand for? Factor. What did we just say factor? What is a factor? Anything that's being multiplied with something else. So what are our factors in this first part of our expression? What are our factors? 2x is one of them. What's our other factor? This whole thing is a factor. Are you guys okay with that? I can't treat them separately. I'm not just going to say x is a factor, 2 is a factor, because this 2 is being subtracted with something else. So this whole thing is a factor, and this whole thing is a factor. What about the next part of it? What about this side? What are our factors? 3 is a factor, and x minus 2 is a factor. Both of these are factors. Are you all okay with that? That's probably the biggest thing that you need to understand. People who get confused with these types of questions don't understand that part of it. What makes them factors? They're getting multiplied. Again, if you don't see a sign in between two sets of parentheses, you assume they're being multiplied. So when you look at this first term, we can treat this as one big term, and this second term, what's the factor that they share in common? This whole thing, right? This is a factor. This is also a factor. So what can we do is we can pull that out as our greatest common factor. So what I just boxed in blue is our GCF. That's the only thing that makes this different, but I'm still going to do it exactly the same way as I did before. I'm going to write that x minus 2 out front. And then what do you get after you divide both of these terms by x minus 2? What do you get for this first one? What simplifies here? Okay, it simplifies to 2x. Is that what you mean? Good, okay. So x minus 2 simplifies with x minus 2, you get 2x as one of your terms. Divide the next one by x minus 2. This x minus 2 is the same as this x minus 2. We still have that 3, so this is 2x plus 3. And this is fully factored. Right, it might not look the way that the other ones did, but I promise it's the exact same thing. As long as it's being multiplied, you can pull it out as a common factor. Let's try something similar with the next one. If I have x plus 3 to the power of 2, remember, what does that mean? What does it mean to square something? Good, right? Multiply by itself. So do you guys agree that I can just write this as x plus 3 times x plus 3? Yeah. All right, good. And then I'm going to write the other one exactly the same. Why does that help us? Let's look at this first set of parentheses before the minus. What are our factors here? X plus 3 and x plus 3. Do you guys agree that these are the things that are being multiplied? Yes. So these are factors. What are our factors here? Good. -4 and the x plus 3. So if you look at this side and this side, what is our greatest common factor? What do they share in common? Nice, guys, an x plus 3. So let's pull one of these out as our common factor. This is x plus 3. Again, this is our GCF. And then to get what's left over here, how do we get that?
You have to divide by x plus 3.
Good, right? Divide everything by x plus 3. All right, and then how does this first set simplify? Good, right? So there's an x plus 3 that cancels. You're just left with an x plus 3. How does this second set simplify? Good, right? These cancel out, and then you're just left with the -4. All right, we'll have plenty of practice with these types of problems. All right. Good, right? So you can, right? Anytime you can simplify a little bit more, you should, right? Do you guys agree that -3 minus 4 is going to get you -1? So then this is going to get you x plus 3 times x minus 1. We're going to do now a difference of two squares. This relates to our special product that we did yesterday, right? Do you guys remember our special product where it was a plus b and a minus b? When you multiply those, what do you get? Good. A squared minus b squared, right? That is our special product. What we're doing now is the opposite of that. We're going to do the reverse. We're going to start here, and we're going to write it like this. All right? So if you have two perfect squares and a minus in between, you can always factor it like this, right? So let's take, for example, x squared minus 4, right? So x squared, is that a perfect square? Yeah, right? Anything squared is a perfect square. Is 4 a perfect square? Okay, good, right? So since these are both perfect squares, you're going to write two sets of parentheses. One gets a plus, one gets a minus, and it's going to be the square root of the first and then the square root of the second. So we get x plus 2, x minus 2. All right, if you don't believe me, you can always FOIL it and then double check your answer and make sure that it gets you this as well. All right. Okay, so let's try some of these. Let's try number 5. Let's look at that first term. 9x squared, is that a perfect square?
Yes.
Yeah. Is 49 a perfect square? Yes. What's the sign in between? Minus. So can we do our difference of perfect squares? Yes, we can. All right, so it's going to be two sets of parentheses, 1 plus, 1 minus. What goes in the first part of it? 3x. Nice, good. And then the next set of parentheses, the next term that we see inside is going to be a 7. Right, remember, square root of the first, square root of the second. This is our final answer, nothing more we have to do. Okay, 7 on the surface looks like it would be the same thing. However, in a few days when we do factoring completely, I'm going to tell you guys, the first thing that you should always look for is a GCF. So I'm going to tell you guys, find the GCF first. And you're always going to want to do that to make sure that you're fully factoring it. Between 4x squared and 100, is there a common factor? 4, good, right? So let's take out the 4. And then when we take out the 4, what's left over? Nice. X squared minus 25, right? Divide everything by 4. All right, when you look at the inside, is there anything special with that? No? Okay, you see perfect squares. Good, Daniel, right? So we see a perfect square here and a perfect square here. We're still going to have that 4 on the outside, but what's our rule with difference of perfect squares?
It's like the square root. Plus and minus.
Good, right? Square roots and then 1 plus, 1 minus. So the square root of x squared is x, and the square root of 25 is 5. So x plus 5, x minus 5. And that is fully factored. All right, when you look at number 8, is 25x squared a perfect square? Yes. Is 36 a perfect square? What's the sign in the middle? A plus, right? So this one's a little bit different. What do you guys think? Can we do our rule? No. This one is not factorable. Not factorable. Right? This rule only works when there is a minus in between two perfect squares. If you don't see a minus in between two perfect squares, you cannot factor. Now you can always check if there's a GCF, maybe you can factor that, but this one doesn't have one. So nothing special there. All right, I'm not gonna do too many of these because we're running short on time. I think the fire drill is gonna start a little bit soon. So I'm gonna do number 10. All right, what do we think we can do there?
You can split 25 into 15x squared minus 1, and then 15x squared plus 1.
Okay, close. It would be not 15, but What do we think? 25. Good. So we can break this down. This is a difference of perfect squares. All right, so this is going to be the same as 25x squared plus 1. Remember, 1 is a perfect square. A lot of people forget that. And then 25x squared minus 1. That's a great question. Do you guys notice that? These are still perfect squares. So can we factor this more? Yes, we can, right? Can this one factor?
Yeah.
No.
That I underlined in blue. No, why not? There's a plus in between, right? Can this one factor? Yes, because there's a minus in between. So that means our answer is going to be 25x squared plus 1. That one didn't change. And then how would the next set of parentheses break down?
5.
Okay, 5x.
Plus 1 and then 5x minus 1.
Okay. Good, right? These are a difference of perfect squares. Nice. All right. So when you look at number 12, all right, it might look a little bit different, but keep in mind it is still the similar process, right? Is this first term a perfect square? Yes, because we see a square. Is this second term a perfect square? Yes, because there's a square. So then we can. And then this is going to be x plus 2 plus y. And then we get x plus 2 minus y. So we can do this, right? This x plus 2 is our first term. That's what's going to stay the same. And then this minus y squared is our second term. That's also going to stay the same. We still did our 1 plus 1 minus. So our rule still applies. Sure, we can do 11. All right. When you look at 11, are 3 and 12x squared perfect squares? No. So what do? Give up? No, right? We take a GCF. What is our GCF here, guys? 3. So you can take out a 3, and then when you do that, what's left over?
1 minus.
Good, 1 minus 4x squared. Divide this one by 3, and then divide that one by 3. All right, our GCF. And then when you look at the inside, 1 minus 4x squared, those are perfect squares, and there is a minus in between. So this is 3, 1 plus, what's the square root of 4x squared? 2x, and then we get 1 minus 2x. Okay, nice, guys. Okay, let's try perfect square trinomials. All right, so perfect square trinomials, again, is just the reverse of the special product that I've been talking about today and yesterday, right? So if you remember, one of our special products was a plus b squared. And the rule for that was a squared plus 2ab plus b squared. Right, similar story if it's a minus. If I have a minus b to the power of 2, that's the same as a squared minus 2ab plus b squared. All right. Whoa, I can't see that. Hold on. Plus b squared plus 2ab plus b squared. Okay. So these special products, again, you guys don't have to memorize them, but it's going to make problems like these a little bit easier, right? Most people get confused at first when doing these, but after a few examples, you guys are going to get it, I promise. All right, so our test for if something is a perfect square trinomial, remember, tri in trinomial means how many terms? 3, right? So these only work with 3 terms. All right. So if you look at something like this, our test for this is you square root the first. What's the square root of x squared? X. You square root the last. What's the square root of 25? 5. You take the sign in the middle. And this should be x minus 5 squared, but we can double check it by multiplying these two numbers together, or these two terms together, and doubling it. So let's do 2 times 5 times x. What does that get you? 10x. Does that match our term in the middle? Yes, so then this does work. This is our factored expression. All right, most people hate that the first time they see it, but we're going to do a couple more. You guys are going to get it, I promise. All right, so let's try something like this. All right, we see trinomials. You guys probably remember from Algebra 1, and I think geometry, you guys did some factoring practice. A different way to factor trinomials, but for the sake of this lesson, this is our only experience with trinomials. Okay, so let's test the first. Let's square root the first. What does that get you? 4x. Let's square root the last. What does that get you? 3. Multiply these together. What does that get you? 12x. Good. And then double it. What does that get you? 24x. Does that match the term in the middle? Yes, so we're going to take the sign in front of the middle and then throw it right in between and then square it. So this is our factored expression. All right, maybe not so comfortable yet. All right, so let me just finish up a couple more. Right, outside of class. All right, let's try number 18. All right, so we're going to test the exact same thing. So I'm going to square root the first. That's going to get you 2x. Square root the last. That's going to get you 1. Let's multiply these together and then double it. And then that does get us 4x, the term in the middle. So I'm just going to stick the sign that we see in front right in the middle and then square it. And then this is our factored expression. I'll finish up with these last two. All right, so let's do the exact same thing with this first one. All right, square root the first. That's going to get you 6y. Square root the last. That's going to get you 7. Multiply these together. That gets you 42y. And when you double it, you get 84y. That does match the number in the middle, so I'm just going to take that sign in front, put it in the middle, and then square it. This is the final answer. All right, let's see if we can do the exact same thing with the last one. Square root the first, that's going to get you 9u. Square root the last, it's going to get you 4v. Multiply them, you get 30. Wait, hang on. Oh, I just messed something up. Sorry. This is going to be 3u and then 4v. Sorry. Okay, this is going to get you 12uv and then double it. That almost gets you the middle, but it's missing a v. Now, I'm not sure if that was a typo or if that was on purpose. All right, if it was on purpose, then we say that this is not factorable. All right, so this, what you have here, needs to be identical to this outside of the sign, right? Whatever sign you see, you would just stick in front. But since this one doesn't match, then it's not going to work out that way. This is just not factorable. All right, and that's all for this lesson.